Good evening, welcome to SAKALAVIDYA YouTube channel. Okay, once again, good evening to you all. Right. Probability part 2. Part 2. Probability part 2. Right, good evening all. First question. The probability that the probability that the probability that a leap year will have 53 Sundays is first option 1/7, second option 2/7, third option is 5/7, fourth option 6/7. This is the question. Right. The probability that a leap year will have 53 Sundays is, this is the question. Probability that a leap year will have 53 Sundays. So that means actually the probability of happening this event, getting 53 Sundays in a leap year, that depends upon the odd days, number of odd days left in that year. For example, in a leap year we have 366 days. And how many complete weeks we have? 7 complete weeks. 52 complete weeks there are. 52 complete weeks means that should be 53rd Sunday, means completely definitely 52 Sundays will get. The 53rd Sunday depend on the number of days remaining on that one. So first let us solve this solution like this. A leap year has 366 days. Now 366 divided by 7. 7 5 ja 35, 16, 7 2 ja 14. That means it leaves remainder 2 days. 2 days will be remainder. That means 366 days and 52 complete weeks. 52 complete weeks. Now the 53rd Sunday depend upon the remaining 2 days. So what are the possible cases for remaining 2 days we need to write? So that is called actually sample space. Remaining 2 days may be like this. Let us say sample space is equal to, you can write Sunday, Monday, Tuesday, Wednesday, Thursday, next Thursday, Friday, Friday, Saturday, next Saturday, Sunday. So these are the cases will arise. So this is called actually sample space. But 53 Sundays. 53 Sundays means it may be, the possible case may be Sunday, Monday or Saturday, Sunday. There are two cases. So that means actually you write down let E equal to event of getting 53 Sundays. 53 Sundays. That means in set E, the favorable cases like this. It may be Sunday followed by Monday or Saturday followed by Sunday. You get 53 Sundays in that leap year. So now required probability we need to find out. What is the required probability? P of E equals to, we have N of E, number of favorable cases upon total favorable cases, N of S. N of E means 1, 2, 2 cases upon N of S, 1, 2, 3, 4, 5, 6, 7, 7 cases. So required probability is 2 by 7. That means option 2 is the right answer. That means you can remember one thing regarding to this question. The probability that a leap year will have 53 any week, 53 any week is 2 by 7. So in a leap year, you remember, in a leap year, probability of 53 any week equal to 2 by 7. 52 means that is 5 by 7. 52 means 5 by 7. Second question. The probability that the probability that a leap year contains 53 Mondays 53 Mondays and 53 Tuesdays. 53 Mondays and 53 Tuesdays. So first option is 4 upon 7. Second option is 2 upon 7. Third one is 3 upon 7. Fourth one is 5 upon 7. This problem is related to the leap year. Already we had a discussion. In a leap year there are 360 days and 52 complete weeks, and remains there will be 2 odd days, either 53 Mondays and 53 Tuesdays, depend upon the remaining 2 days. So remaining 2 days means actually we can write like this now. First of all, solution follows. Sample space is equal to remaining 2 days will be like this: Sunday, Monday, Tuesday, Wednesday, Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, and Saturday, Sunday. Total 7 cases. In that 53 Mondays and 52 Tuesdays, that means the 2 days must be Monday and Tuesday. That will be only one case. So this is the favorable cases. Monday followed by Tuesday. Monday followed by Tuesday. Monday, Tuesday. So first day, Monday, next day, Tuesday means they in that year compulsory 53 Mondays and 53 Tuesdays. Therefore now write down let E be the event of getting 53 Mondays, 53 Mondays and 53 Tuesdays. That implies here E equals to favorable cases Monday followed by the Tuesday. Now we need to find out probability. P of E equals to, as per the definition of the classical probability, N of E upon N of S. N of E means only one order pair, 1. Here how many order pairs we have? 7. 1 upon 7. Only one possible case out of 7. So answer is 1 by 7. So that means first option I need to change. This is 1 upon 7. 1 upon 7. Understood now? Here and is very important. You remember, and means this is called actually inclusive sense. This is called inclusive sense. Inclusive sense. Or means exclusive sense. Now third question. Question number 3. Question number 3. The probability that a leap year contains 53 Sundays or 53 Mondays. You see that this keyword is R, is. First option 4 upon 7, second option 1 upon 7, third is 3 upon 7, fourth is 2 upon 7. This is the question. Right now, here probability that a leap year contains 53 Sundays or is the keyword 53 Mondays, or is called actually here exclusive sense. 53 Sundays, 53 Mondays in a leap year. That means let us make a plan like this. Let A be the event of getting 53 Sundays. B be the event of getting 53 Mondays. R means union, A union B. P of A union B. P of A union B is equal to P of A plus P of B minus P of A intersection B. P of A intersection B means both Sunday and Monday. There will be one case. So like that we need to do. We need to apply here probability, addition theorem on probability we need to apply. So solution write down. Here leap year means yes we know. So that means actually you can write like this. A means getting 53 Sundays. B means getting 53 Mondays. A intersection B means that getting both. So what we need to find out means P of A union B, either A or B. P of A, probability of getting 53 Sundays, plus P of B, probability of getting 53 Mondays, minus probability of getting 53 Sundays and 53 Mondays. P of A intersection B. What is probability of P of A? There will be two cases. 53 Sundays means 2 upon 7 plus this also 2 upon 7 minus this will be only one case, 1 upon 7. 7 is the LCM. 4 minus 1 is 3 upon 7. That means this one. Yes, 1 upon 7 plus 2 upon 7. Because there is a chance to two cases, 2 upon 7 plus 1 upon 7. You will be getting 3 upon 7. Fourth problem. Right. The probability of getting the probability of getting exactly two tails in 6 tosses of a fair kind is first option 3 upon 8, second one is 1 upon 4, third one is 15 upon 64, fourth is 49 upon 64. So all of you read the question. So all of you read the question, look at the screen. The probability of getting exactly two tails in 6 tosses of a fair kind. Fair kind means sometimes in the examination that may be given that symmetrical kind. A fair kind is tossed for 6 times. That means a kind is tossed for 6 times is same as 6 kinds are tossed simultaneously. Same meaning, same sense. So that means actually here see the probability of getting exactly two tails, 6 tosses of a fair kind. So that means first of all we need to write S or N of S. N of S means here kind is tossed for 6 times means each kind has actually two cases. 2 cases in a sample space. 6 tosses. That means 2 into 2 into 6 times 2 to the power of 6. So now we need to write n of s is equal to sample space. Number of elements in sample space is equal to 2 raised to 6. That is equal to 64. Now the probability of getting exactly 2 tails. Let E be the event of getting exactly 2 tails. So therefore now n of e is equal to nothing but n of e is equal to the number of ways of selecting 2 tails from 6 tails, because there are 6 tosses. 6 tosses means there is a total possible of getting tails are 6 tails. Out of 6 we need to select 2. That can be done 6 C2 ways. 6 C2 is equal to 6 times 5 upon 2 times 1. This will be 15. So now we need probability P of E. P of E equals to n of E upon n of S. So we'll get 15 upon 64. So third option is the right option. Third option is the right option. I hope you might have understood this problem. The probability of getting exactly 2 tails. 2 tails means out of 6 tails 2 has to be selected for the favorable cases to the n of e. Total without any restriction is actually 64. Out of 64, 15 are favorable. The probability is 15 upon 64. Right. Fifth question. If n kinds are tossed simultaneously, the probability of getting head an odd number of times, the probability of getting head an odd number of times is first option 1 upon 2 power n, second option is 1 upon 3, third 1 upon 2, fourth 1 upon 2 power n minus 1. This is the question. All of you read the question. This time n kinds are tossed simultaneously, or a coin is tossed for n times is same. Results are same. The probability of getting head an odd number of times. Odd number of times means here if n coins are tossed, so there are n possible cases, n number of heads may come. Out of n we need to select each time odd number. That means how can you select it now? 1 can be selected, 1 head can be selected, 3 heads, or 5 eighths or 7 eighths or 9 eighths and like that. But there is a chance either or. So that's why we get favorable cases is NC1 plus NC3 plus NC5 and so on. So let us write it now. If n coins are tossed simultaneously, the probability of getting head an odd number of times, this is the keyword, odd number of times. That means now the solution, let us find out. As n coins are being tossed simultaneously, n of s becomes 2 into 2 into n times 2 to the power of n. Now let E be the event of getting head an odd number of times. That means odd number of times means 1 head or 3 head or 5 heads or 7 heads or 9 heads and so on. Because here we have n, we do not know, that is a finite quantity, but n times, as it has been actually tossed n times, mean n coins are tossed simultaneously. That means the chance of getting 1 head or 3 head or 5 head, 7 head, 9 head, now they treated as event of getting head only for odd number of times. That means now n of E is equal to, we can write n of E is equal to, out of n heads we need to select one, NC1, or means in mathematically we can write plus NC3 plus NC5 plus NC7, NC9 and so on. Using binomial theorem, C1 plus C3 plus C5 plus C1 plus C9 equal to C0 plus C2 plus C4 plus C6, 2 to the power of n minus 1. Now we need to find out probability, P of E. Therefore, P of E equals to, so today pen is not working properly, P of E equals to n of E, number of favorable cases, total outcomes, 2 to the power of n minus 1 upon 2 to the power of n. Now this can be written 2 to the power of n minus 1 upon 2 to the power of n minus 1 into 2. Can I write like this? Any doubt? Any doubt? Right now 2 to the power of n minus 1, 2 to the power of n minus 1 cancel 1. Answer is 1 upon 2. Third option you will be getting. That means actually here the probability of getting head an odd number of times does not depend on value of n. Here n may be any value, always you can say 1 by 2 answer. For example, the same question is asked like this. If 20 coins are tossed simultaneously, the probability of getting head an odd number of times is, answer is 1 by 2 only. Answer is 1 by 2. Not only 2020, next year also, 2021 times also, answer is 1 by 2. All of you understood? So now you can create your own question. Sixth question. Right, sixth question. The probability of getting a total of 10 in a single throw of two dice is first option 1 upon 9, second option 1 upon 12, third option is 1 upon 6, fourth option 5 upon 36. Right. The probability of getting a total of 10, a single throw of two dice. That means two dice are rolled simultaneously. Then the probability of getting a score, total means score or total is same, score of 10 is we need to find out. That means if two dice are thrown at random, the probability of getting a score of 10, that we need to find out. So that means now this problem is related to the two dice. Two dice means without any restriction, the total number of outcomes in a sample space n of s is equal to 6 into 6, 36. So first let us proceed like this. Solution n of s is equal to 2 dice 6 into 6, 6 square, whose value is 36. So now let E be the event of getting a total of the dots turned up on two dice, total 10. So now the possible cases for E radon. What are the possible cases? On first die 2, second die 8, 3, 7, 4, 6, 5, 5, 6, 5, 5, 4, 6, 6, 4. So that means actually here now what happens now, these two are invalid. So that's why we need to try again. So that means what do you get now here? 2, 8 is not possible, 3, 7 is not possible, 4, 6 and 6, 4 and 5, 5. Only 3 cases are possible. 4, 6, 6, 4, 5, 5. Therefore, n of E equals to 3. Now P of E equals to n of E upon n of S. So that is equal to 3 upon 36. So 1 upon 12. This is the answer. Now shortcut. What is the shortcut? This is the original method. We have the shortcut also. P of score 10 equal to divided by 36, because 2 dice, 10 means 13 minus 10 rather. 13 minus 10 is equal to 3 by 36. 3 by 36 is equal to 1 by 12. You check it. Selection. So 6 on first die 4 and second die 6. First die 6, second die 4. First die 4, second die 4. That's why here two different cases we will get it. Right. This is the shortcut. You may call super shortcut or whatever shortcut. But always remember, whenever more than 7 score is there, you need to subtract from 13. You need to subtract from 13. So that is the logic, Suma. You need to remember. That is the logic. So less than 7 means score minus 1. Greater than 10 means 13 minus score. You remember. 13 minus score by 36. Seventh. 2 dice are rolled simultaneously. Simultaneously means at once. The probability that the the numbers on them are different. First option 5 upon 6, second 1 upon 4, third 1 upon 2, fourth 9 upon 13. This is very important problem. 2 dice are rolled simultaneously. That means at one time 2 dice are rolled. The probability that the numbers on them are different. So numbers on them are different means, actually this is very logic question. On first die the chances are 6. The same number will not come on the second die. And for second dice we have the 5 chances. That means 6 into 5. 6 into 5 total is 36. 30 by 36 is the answer. So that means now the solution we can write like this. N of S is equal to, so first die, second die, 6 into 6 is 36. This is total outcomes. Let E be the event of getting different numbers on them. So that means this is the first die, the second die. On first die 6 chances, different number means that should not repeated. So 5, 6 into 5. So that means N of E is equal to, we can write 6 into 5 is 30. Therefore P of E, N of E upon N of S, 30 by 36. 6 into 5 upon 6 into 6. So 6 1 ja 6. So 5 upon 6 is the answer. First option. Now, eighth problem. If two unbiased dice are rolled, then the probability of getting a prime score, prime total or prime score. First option 5/12, second option 5/6, third one 5/36, fourth option 2/5. Right. Two unbiased dice are rolled at a time simultaneously. Then the probability of getting a prime score. Prime score means prime total. Prime total means actually the score ranges from 2 to 12. Out of 2 to 12, what are the primes score you need to see? Prime score. Prime score will be like this. Either 2 even prime, 3, 5, 7, 8, 9, 10, 11. Only 1, 2, 3, 4. Either 2 or 3 or 5 or 7 or 11. That means getting a score 2 or getting a score 3 or getting a score 5 or 7 or 11. That means here 1, 2, 3, 7. That means 7, 1, 2, 3, 4, 5 probabilities we need to find out and we need to add. 2, 3, 9 is not a prime number. 9 is not a prime number. 9 is not a prime number. So that means now you can follow the solution like this. P of prime score equal to, you can write P of 2 or 3 or 5 or 7 or 11. R means actually exclusive sense. Whenever R is there, you need to add. That means P of score 2 plus P of score 3 plus P of score 5 plus P of score 7 plus P of score 11. So now whole divided by 36. Am I correct now? Score 2, score minus 1, 2 minus 1, 1 plus score 3, 3 minus 1, 2, 5 minus 1, 4, 7 minus 1, 6. This is more than 7. 13 minus 11 is 2. This equal to 8 plus 4, 12 plus 2, 14, 15/36. So 3 5 ja, 3 12 ja. Required answer is 5/12. This is the answer. 5/12. So for example, R be the score. Two cases. R is less than or equal to 7. P of R equals to R minus 1/36. You remember this shortcut. R is greater than 7. P of R is equal to 13 minus R. by 36. You remember this shortcut. Okay, this tip you remember. Right. Ninth problem. 3 dice are rolled. 3 dice are rolled simultaneously. Simultaneously. The probability that the probability that the probability that the sum of the numbers on them is 16 is 3 dice are rolled simultaneously at once at one time. The probability that the sum of the numbers on them is 16. The score on them is 16. This time not 2 dice, 3 dice. 3 dice are rolled simultaneously. You remember. Whenever 3 dice means n of s is equal to 6 into 6 into 6. 216 cases you will get it now. Out of 216, what are the favorable cases we need to find out. There score 16. Score 16 means possible cases we need to select. But we have the shortcut that tomorrow I will explain the shortcut for even 3 dice also. Three dice are rolled simultaneously. The probability that the sum of the numbers on them is 16. Solution right on. The problem is 3 dice, related to 3 dice. 3 dice are rolled simultaneously or a die is rolled for 3 times is same. So n of s equals to on first die 6 results and second die 6, third die 6. This is 6 raised to 3, 216. Let E be the event of getting a sum or score 16. That means first take the 3 dice like this. First die, second die, third die. What are the possible cases? Let us write it now. Possible cases. On first die, actually it may come like this. On first die, okay, the sum of the numbers on them is 16. Okay, 16 means what are the cases we can get it now? Here, first case you get like this now. On first die 6, second die, first die 6, second die 6, on third die 2. 6 plus 6, how much? 12. 12 plus 2 is 14 only. 664. Second case, next 6, 5, 11. 6 plus 5, 11, 11, and also we need 5. 6, 5, 5. Okay, any other cases now? Any other cases? No cases, only 2. 6, 6, 5, 6, 6, 5, 5, 6, 6. Okay, 5, 5, 6, 6. 6, 6, 6 plus 6 is 12, 12 plus 5 is 17. That cannot be possible. That cannot be possible. That cannot be possible. Okay, that means only these are possible now. 2 cases are possible. 6, 6, 4. 6, 6, 4 means we can arrange like this now. See, now E equals to, we can write like this. 6, 6, 4. 6, 4, 6. We can write 4, 6, 6. Next, this we can write 6, 5, 5. Next, we can write 5, 6, 5. Next, we can write 5, 5, 6. So these are the favorable cases. So that means n of E equals to 1, 2, 3, 4, 5, 6 cases. That means n of E we need to find out. Sorry, P of E we need to find out. P of E equals to n of E upon n of S. So 6 upon 216. That is 1 upon 36. This is the answer. This is the answer. Okay. That means these 6, 6, 4 can be rearranged in 3 on 3 dices like this. 3 ways. 6, 5, 5 is also 3 ways. Total 6 ways. 6 out of these 260. So 6 divided by 216 is 1 upon 36. 1 upon 36. Okay, options I haven't given, but options you write on. First option is 1 upon 36. Second is 1 upon 108. Third one is 26 by 51. Fourth option is 13 upon 34. So it's obviously first option with the right option. Okay. So let us move to the next problem. Here very clear that on first die 6, second die 6, on third die 4. 6 plus 6, 12, 12 plus 4, 16. Sum is 16. Or on the first die 6, second die 5, third die 5, total 16. But they can be rearranged themselves. These 6, 6, 4 can be arranged 3 factorial by, here 6 repeated, 2 factorial. That means 6 by 3. 6 by 2 is 3. Similarly, 655 can be arranged 3 factorial upon 2 factorial ways. That is 6 by 2 is 3. Total 6. Total 6. So that also I have written. Tenth one. So 10th one. 6 faces. 6 faces of a dice are marked with numbers 1, -1, 0, -2, 2, 3, and the dice is thrown thrice, 3 times. The probability that the sum of the numbers on them is 6. Sum must be 6. Now is first option 3 upon 216, second option 6 upon 216, third option 10 upon 216, fourth one is 18 upon 216. Right. Here it is not a symmetrical dice, it is a magical dice. A magician rolled a dice. Generally on each dice 1 to 6 we have, but it is a not symmetrical die, it's not a fair dice, but in that numbers are marked as 1, -1, 0, -2, 2, 3, but 6 faces have 6 faces has the numbers. The numbers are from 1, -1, 0, -2, 2, 3 itself only. But it is not actually symmetrical problem, means we can apply the shortcut. It's not a symmetrical problem, but we need to do it. So let us do it. How to do this problem? Here 6 faces of a dice are marked with these 6 numbers. Probability that is 6. Score must be 6. So now 10th solution. N of S is equal to how many times? Thrice, 3 times. 6 times 6 times 6. This will be obviously 216 only, because there are 6 numbers only. But now let E be the event of getting a sum or score 6. So let us write possible cases now. This is the first time die rolled, second time rolled, third time rolled. Possible cases we need to write to get sum 6. What are the possible cases? You can write on first die 1, second 2, 3. They can be interchanged. 3 plus 2, 5 plus 1, 6. Okay. Second may be on first die 0, 3, 3. Yes, 6 we will get it. Next, third may be on first die 2, second die 2, third die 2. Are there any cases will arise? Are there any cases other than these cases? So that means now here N of E equals to, we can write either case 1 or case 2 or case 3. 1, 2, 3 can be arranged 3 factorial ways, plus 0, 3, 3 can be arranged in 3 factorial, but repeated 2 times 3 upon 2 factorial plus this will be 3 factorial upon 3 factorial. This is equal to 6. 6 by 2, 1. 6 plus 3 plus 1. Total 10 ways. Total 10 ways. Therefore, by the definition of the classical probability, P of E equals to N of E upon N of S. So 10 upon 216. 2 5 ja, 2 10 ja, 20, 16 2 8 ja. 5 upon 108. This is the desired answer. 10 upon 216 may be answer, or if you simplify you get pi upon 108. What is the right option? Yes, third option, not simplified. So 10 chances out of 216. So you might have understood this question. This question need to be done using permutations concept. That's why permutations and combinations are very, very important. They play vital role for even probability chapter 2. Probability chapter. Now 11th question, right. If two cards are drawn, from a well-shuffled pack of cards. The probability that at least one of two is heart card. It must be from the heart shoot. At least one of them. First option 4 upon 13. Second option is 11 upon 13. Third one is 55 upon 221. Fourth one is 15 upon 34. Right. So this problem need to be actually divided into the two parts. What are the two parts means? Here see, first part, two cards are drawn from a well-shuffled pack of cards. This is the first part. First part means I can ask you one question. So what is the question means? How many ways can you draw? Can you draw two cards from a well-shuffled pack of cards? Or how many number of ways can you select two cards from a well-shuffled pack of cards? That is, out of 52 cards, you need to select two cards. That is the one problem. So that is our N of S, the number of total outcomes, N of S. So that means here N of S is a problem for us. First part, N of S is equal to the number of ways of selecting two cards out of a pack of cards of 52. That can be done 52C2. Okay, leave it now, 52C2 write down. Next, second part, the probability that at least one of them is heart card. P of at least one heart card. So that I will give the one, this we need to find out. For example, say this event is E. That means P of E equals to, we can write 1 minus P of no heart. Both should be not heart cards, no heart. So P of no heart means actually here no heart cases means, so with excluding heart shoot, from remaining 3 shoots we need to select. That we remaining are how many? 13, 13, 13, 13. Total there are 39. Out of 39 we need to select how many? 2. So that we can done 1 minus 39C2 upon total is n of s 52C2. So 1 minus 39 into 38 upon 2 factorial, here also 2 factorial cancel, 52 multiplied by 51. See 31 3 ja, 13 3 ja, 13 7 ja. Now 2 19 ja, 2 26. Okay. 2 19 ja, 2 2 ja, 4. Okay. This will be 26. 26. 52 into 51, 39 into 13. Okay. Right. 39 into 13. Okay, I will do simplification like this now. This is 39 into 38 upon 52 into 51. 39 3 ja, 39 4 ja. Okay. Now 2 2 ja, 2 19 ja. 3 1 ja, 3 17 ja. That means 1 minus 19 by 34. So 34 minus 19 is how much actually? 34 minus 19. 34 minus 19 is 515. So this will be 15 by 34. So fourth option is the right option. Fourth option. So all of you check it now. Right. Okay. So if you have any other methods, you can adopt it, no problem. But I explained my level best. Okay. If you have any new methods, you can, after completion of this session, so you can chat in the chat box. So thank you. Bye bye. See you. Tomorrow class may be 8:20 or in between 8:25, morning 8:25 to 9:25. After that I have other session for other engagement is there, so that the class will be free phone to 8:25 tomorrow morning. Okay, bye. But really actually the calculation part you need to do it. Only I will explain the concept, better thing. So